This is 4.3, linear systems in three variables. We're going to solve systems like we have been doing that are in what's called row echelon form using back substitution. And then we're going to solve systems using the Gaussian elimination method. So first off is, what is row echelon form? The system on the right here is in row echelon form because each leading coefficient is 1, right? 1x, 1y, and 1z. And it's a stair-step type of pattern where this has an x, but this one doesn't. Okay, it just has a y. It can have a z, it doesn't have to. But as long as it has a y and this one has an x. And then the third one can't have an x or it can't have a y, it just has a z. Okay, so it's in this stair-step pattern where each coefficient in the lead is the number 1. That's row echelon form. So when we get it in row echelon form, it's easy to solve. We're going to use back substitution. Okay. Later we'll talk about how we go from a system looking like this into a system that's in a nice row echelon form. But first, let's look at one in row echelon form, and we're going to solve this system. Remember, to solve it means to figure out what x is, what y is, and what z is. Well, luckily, for starters, we know that z equals 3 because of equation 3 here. Okay, so that was step 1. Step 2 is going to be to find the value of y. Well, if we know what z is, we can take this 3 and plug it in for z. We're going to back substitute it into equation 2, into the equation above. So in step 2, I'm taking equation 2, it says y plus 2z, and I'm plugging in 3 for z's place. And I'm solving this and simplifying. Subtract 6, and y equals -1. Okay, so we have what y equals, we have what z equals, we just need to find out what x equals. So in this top equation, it's the only one that has x in it, right? So we need to plug in for y and for z, simplify that, and figure out what x equals. So that's going to be our step 3. Take your equation 1 and substitute in -1 for y and 3 for z and solve this. So a -2 times a -1 would be a +2. And a 2 times a 3 would be a 6. I'm going to combine these like terms. It gives me x plus 8 equals 9. Subtract 8. And x equals 1. So I know what x is, y is, and z. Just like we have an ordered pair, we're going to have an ordered triple since there's 3, not just 2 answers. So an ordered triple, x comes first, so 1, and then y comes second, and then obviously z will come third. So instead of an ordered pair, we have what's called an ordered triple for our final answer. Okay, so not all systems are going to be in this row echelon form. The only reason we could use back substitution is because it was in row echelon form. So how can we manipulate systems to get them in that form? Well, there are 3 things that we can do that doesn't change the value of a system. Okay, I can't just, let's say we started with this system, I can't just randomly make this into row echelon form. There's certain mathematical processes that I have to do, right? And just like when we solved a system in 2 equations, we could interchange those 2 equations, which means the same as just switching the order. Okay, so switching the order means maybe maybe I wanted to put this equation up here and the first equation in the second row. Okay, that's all it's doing. It's not going to change the value. It's still the same system if I switch the order that these are in. So that's one thing we can do. The other thing we can do is multiply the entire equation by a non-zero number. And just like we did in systems with 2 rows instead of 3 rows, right? We could take x plus y equals 10, and I could multiply that entire equation by -2, right? We did that to solve some systems. And the third thing that we can do that won't change the value is add 2 equations to eliminate a variable. Okay, just like we did again with 2 row systems, I could take these equations and I could add them together, right? Adding them together would give me a new second equation. Okay, but remember that the first equation, the top equation, is going to stay the same. Adding these together gives us a new second equation. But the first equation, this is important, it stays the same. Okay, so these 3 operations are what we call row operations. Row operations are used to produce a row echelon system. Okay, and when we do that, we call this the Gaussian elimination method. And just so you know, Gauss, he is an old mathematician, and Gauss rhymes with house, just so you know how to pronounce that. Okay, so we're going to use these 3 row operations in order to take a system that's not in row echelon form and put it into a system that is in row echelon form. Okay, so let's start with this system of linear equations, and we have 3 variables, and we're going to use the Gaussian elimination method. So to start off, remember, if we want it, our goal here is to first get it in row echelon form, which means the first equation has to have a 1x, and then it doesn't matter what comes after that. So it looks like our equation 1 is good. The leading coefficient here is 1, and it has an x. Okay, well, what does our second equation need to look like? Well, it can't have an x, and this leading coefficient has to be a 1. But I can't just get rid of that, you guys, right? That would change the system entirely. That would not be the same problem. So I have to use these 3 row operations in order to get rid of this x and change this 3 to a 1y. Okay, so to start off, we're going to leave equation 1 alone, okay, because the x in the upper left has a 1 in front of it. So leave equation 1 alone. We need to manipulate equation 2. Okay, and I would encourage you to write small on this and kind of keep it organized as I keep my slide organized. That will help you save room on your paper and make sure that this whole problem fits. Okay, so step 1 is I need to eliminate this x, right? And we know all the steps to do this, guys. We've done 2 variable systems before. So let's think about it as just these 2 equations to start off with. If I was working with these 2 equations, how would I eliminate that x? How would I get rid of it? Well, they match in number, right? There's a 1 in front of both x's, and they differ in sign. One's positive, one's negative. So when they match in number, and when they differ in sign, I can add the equations together. So for step 1, I'm going to take my equation 1, and I'm going to add it with equation 2. Okay, one thing I want to point out is when I'm writing my z's, I put a line through my z. That way I know what numbers are 2's and what letters are z's. It really helps to keep track. So I would encourage you to start forming that habit of putting a line through your z. I also left a space here because there is no z in this second equation. So I'm just kind of leaving it blank. So I'm lining up my equal signs essentially. Okay, so what happens when I add these together? Well, 1x minus an x, those zero out. I have negative 2y plus a 3y, so that'd give me 1y. I have a 2z plus 0z, so that's 2z's. And a 9 plus a negative 4 would be a 5. Okay, so remember what the row operation says. We can add two equations to eliminate a variable. We did that. We just added two equations together. Now remember what it says. It says the first equation stays the same. So what I'm going to do over here is I'm going to rewrite this system that we have going on. Okay, the first equation that we used in this addition stays the same. But look what changed was our second equation. We eliminated the x in the second equation, and now we just have y plus 2z equals 5. And we still have this third equation. Okay, so don't count it out just yet. He's still there. He's just hanging out. We haven't touched him really yet. Okay, so that's our system as of now. We're pretty close to row echelon form, right? I have a 1x and a 1y, but now I need to start manipulating this bottom equation. This x has to go away. I don't want him there at all. Yes, I don't want the y there at all either, but let's get rid of the x first. Okay, so how am I going to get rid of this x? It needs to be eliminated, right? So what other equation has an x in it so that I can eliminate? Well, it would be the top equation. The top equation is the only one that has an x. So I know I'm going to be using the equation 1 and equation 3. So my next step is to eliminate this 2x by using equation 1. Okay, so what do I need to do to equation 1 so that I can eliminate with 2x? Well, remember, I need them to match in number but differ in signs. So I need this x to be a 2, but a negative 2. So what am I going to multiply by? A negative 2. Now remember, I can't just multiply the x by a negative 2. I have to multiply the entire equation. So I put it in parentheses, and I'm going to distribute that negative 2 to now all 4 items. When I do that, I get negative 2x plus 4y minus 4z equals negative 18. Okay, so all I've done was just changed my equation 1 to match equation 3, right? I haven't yet eliminated equation 3's x value, which is what I want to do now. Okay, so I'm going to add it with equation 3, which is 2x minus 5y plus z equals 10. Remember, I can add two equations together, and my x's are going to eliminate. 4y minus 5y is a negative 1y. Then I have a negative 4z plus 1z, so that'd be a negative 3z. And negative 18 plus 10 would be negative 8. Okay, so I'm going to again write my system that I have. Equation 1 has not changed. Yes, I multiplied it by a negative 2, but that was just to eliminate. Okay, so it's still equation 1 like I had before. Equation 2, I didn't touch at all. It's still equation 2. But equation 3, look how I got rid of this 2x. I eliminated that. So equation 3 is just negative y minus 3z equals negative 8. Okay, so we're getting somewhere. We're working our way down, right? I still need to get rid of this y. For it to be in row echelon form, this equation 3 can only have a z. So how am I going to get rid of this y? Well, again, I need to eliminate it with another equation, right? You're only ever going to be working with two equations off to the side here. So which equation does it look like would be easiest to eliminate this y? Well, it looks like these two, right? So in step 3, I'm going to be using equation 2 to help me eliminate equation 3. Do I need to multiply equation 2 by anything for it to match the y's? No, they have the same number in front, and that number differs in sign. One's positive, one's negative. So I'm ready to eliminate. I'm just ready to add those two equations together. Because when I add the equation 2 with equation 3, my y's cancel. A 2z plus a negative 3z would be a negative z. And a 5 plus a negative 8 would be a negative 3. Okay, so what equation did I just change? That was equation 3. So let's rewrite our system again, just so we're keeping track of what all's going on. I do this every problem. I know it's showing a lot of work, but it seriously can get so confusing at times that being organized on these problems will help you a lot. And equation 3 is now negative z equals negative 3. Okay, so what has happened here? Oh, you guys, why did I do this? How did that x become negative? Just by mistake, I suppose. Okay. What has happened? Well, I'm pretty darn close to row echelon form. I have a 1x, a 1y, I just need a 1z, but right now it says negative z. So I need to manipulate it. It cannot be a negative z, it has to be a 1z to be in row echelon form. So my fourth step would be to multiply the third equation by a number so that the coefficient is 1. Well, that number, if I'm going to take negative z equals negative 3, and I want it to be a positive z, I need to multiply it by a negative 1. But I can't just multiply the z, remember, it has to be the entire equation. So I need to distribute it. Negative times a negative would be a positive. So I get z equals 3 for my final equation 3. So equation 1 hasn't changed. Equation 2 hasn't changed in a while. We changed it at step 1. And equation 3 we now figured out is 1z equals 3. So this is my final row echelon form. Now, Skyward might ask you, solve the system of linear equations. This isn't solved. This is just put in a certain form that helps us solve. So technically, our step 5 would be to do what? Well, once we get it in row echelon form, we're going to back substitute to find the solution. Now, if you'll notice, this is the same exact problem as we did here. So I already know that my answer is going to be the ordered triple of 1, negative 1, 3. Right? Z was 3, plug it back in for y and for x. Okay, so that's the Gaussian elimination method. We just keep eliminating these until we get it into row echelon form, and then we're going to use back substitution to solve. So let's look at another problem. Okay, this system is not in row echelon form, so we need to use the Gaussian elimination method to put it in that form in order for us to back substitute and solve the system. So one thing I noticed is that equation 3 has a leading coefficient of 1 on the x, and I'm kind of thinking, hey, that would be handy if that was in the top, right? Instead of getting rid of this 4 and changing it to a 1, it'd be a lot easier just to switch equation 1 with equation 3. I'm going to interchange them. That's a row echelon, that's a row operation that we can do, is interchange. So for step 1, that's what I'm going to do. switch equation 1 with equation 3. So what would that new system look like? Well, nothing's changed except the order in which they're written. So I'm going to move equation 3 to the top of the order. Equation 2 stays the same. And then move the top equation down to the bottom. Okay. Now, first equation's good. I don't need to manipulate it anymore, but I am going to use it to help me manipulate equation 2, right? Because we need this x term to cancel. I just need a y there. So how am I going to cancel that x? Well, I'm going to use equation 1 to help me do that. And what do I need equation 1 and equation 2 to look like? Well, they need to both have a 2, but one needs to be positive and one needs to be negative so that I can eliminate these x's, right? We've done this before. We've taken an equation or a two row system and I've eliminated a variable. So I'm going to eliminate the x, but in order to do that, I need to multiply this top equation by a negative 2. Okay, so step 2 here, again, we're writing small on these, is to take your top equation and multiply it by negative 2. Remember, I'm multiplying everything by negative 2, including the y, z, and the 3. A negative times a negative would be a positive. Okay, so I've changed equation 1, just a manipulation for now. It's not permanent. Okay, I multiplied it by a negative 2 so that I can add it with my second equation, and therefore my x's are going to cancel. A negative 2 plus a negative 3 would be a negative 5y, and a negative 2z plus a positive 2z, those would cancel also. There would be 0 z's there. And 6 plus 9 is 15. Okay, so let's go ahead and write our new system. All right, equation 1 still the same. I'm just manipulating it in order to eliminate, but it's not permanent, remember? But what did change was I eliminated the x value in the second equation, and now the second equation is just a negative 5y equals 15. My third equation I haven't touched, so I'm just going to copy it back down. And that's what I have going for me so far. Now, how do I take this system and get rid of this x in the third equation? Well, I have to eliminate it with another equation. So I need to use the only other equation with an x. So I need to use equation 1 to help me get rid of this 4x, just like I did in step 2. So step 3, what does this x value need to be? It needs to be a negative 4 since this is a positive 4. So because it needs to be a negative 4, I'm going to multiply the top equation by negative 4. So I get negative 4x minus 4y minus 4z equals 12. Now that it's a negative 4x, I can add it with the third equation, which is 4x plus y minus 3z equals 11. Okay, so my x's cancel. Yay, that's what I wanted. This 4x is gone. And now I have a negative 4y plus 1y, so that's negative 3y's. Negative 4z plus a negative 3z, that's negative 7z. And then I have 11 and 12 added together, so 23. I'm going to go ahead and write down this new system so I don't forget what's going on. You have to keep track step by step what your system looks like. Otherwise, you're going to get lost badly. Equation 1. Equation 2. And equation 3 is now negative 3y minus 7z equals 23. Okay. One thing that I want to do, or actually I need to do a couple things. I need this y value gone, and I need this y value to be 1, right? To be in row echelon form. The bottom equation can't have a y, and the second equation has to have a leading coefficient of 1. So something that looks easy for me to do right now is to change this second equation to be a 1y. So in order to do that, remember our row operations say that we can switch things around, we can multiply an equation by a number, or we can add equations together. Those are the only 3 row operations I have. So how am I going to get this to be a 1y? Well, I'm going to multiply this equation by a number. And that number needs to do the same thing as if I were to say, if I get, let me put it this way. If I gave you this equation, negative 5y equals 15, how would you figure out what y equals, right? Or what 1y equals? Well, you would probably tell me, well, Miss Eck, if you just want a y, go ahead and divide by negative 5. So those cancel and you get a y. Sure, you could do that. But technically, our row operations say we can only multiply. We can't divide. So what is multiplying that does the same thing as dividing by negative 5? Well, if I were to multiply by negative 1/5, that's the same as dividing by negative 5. Okay? Just like dividing by 2 is the same as multiplying by 1/2. Okay? That's what I'm going to do here. I'm going to multiply by negative 1/5. If in your brain you're thinking divide by negative 5, perfect. Divide by negative 5. I'm going to follow the row operation rule, which says we got to multiply. Okay, so a negative 1/5 times a negative 5 would be a positive 1y. And a negative 1/5 times by 15 would be a negative 3. Again, it's like dividing by negative 5. So that's my new equation. What equation was I just working with? That's my new equation 2. So don't change any other equations here except for equation 2 is now 1y equals negative 3. Okay, so my equation 1 and my equation 2, they're good. They're golden. Leading coefficient of 1, it goes x, and then it goes y. Now I just need to get rid of this y so that I have a z here. Okay, so I need to eliminate a y. Pick another equation that looks easy to eliminate that y with. Well, most often it's going to be the one right above it. Okay, if I can get this y value to be a positive 3, then I can add the 2 equations together and we're good. So I'm going to use, in step 5, I'm going to use equation 2. But in order to use it, remember, it's got to be a positive 3 to match up with this one. So I need to multiply equation 2 by a 3, which would give me 3y equal to negative 9. That's equation 2. I'm going to take that equation 2 and I'm going to add it with equation 3. Okay, so adding these 2 equations together, now my negative 3y cancels just like I wanted it to. I have 0z plus a negative 7z, so that's negative 7z. I have a negative 9 plus 23, so that would be negative 14. Sorry, positive 14. Okay, and that's my new equation what? What did I manipulated equation 2 to help me eliminate that y in equation 3, so this is my new equation 3. So let's go ahead and write that in. So I'm going to write negative 7z in the z column equals 14. Okay, so it kind of resembles row echelon form, but what do we need to do to fix equation 3? Well, equation 3 cannot have a negative 7 there. It needs to be a positive 1. So the last thing I want to do is to get that negative 7 to be a 1, which means I need to multiply the third equation by negative 1/7. In other words, divide by 7, right? Just like up here I divided by negative 5. Means the same exact thing. So in step 6, I'm going to multiply this equation by negative 1/7. And when I do that, I distribute it. I get a positive 1z and a negative 2. So my new system, my new third equation is z equals negative 2. Now I'm in row echelon form. I have a 1x, then a 1y, then a 1z. I'm good. However, it didn't just say put it in row echelon form. It said solve the system. So I need to solve it. I need to get an x, y, and a z value. So my step 7 is going to be back substitution. Okay. So let's take our row echelon form and back substitute. Good news is, folks, in our ordered triple, we already know that z is going to be negative 2. Right, from our third equation, z equals negative 2. Got one of them. So let's also look at equation 2. It says y equals negative 3. Oh my gosh, I already know what y equals. Okay, so now if I know z and I know y, I'm going to back substitute them, these two values, into the top equation 1, which says x plus y, which is now negative 3, plus z, which is negative 2, equals negative 3. I'm going to combine my like terms. So I get x minus 5 equals negative 3. Add the 5 over. And I get x equals positive 2. So I can put that in the x position, and I have just solved this. So the hard part, folks, is putting it in row echelon form. The back substitution should be easy peasy. If you have any questions about what went on here, or maybe you're not even sure what questions to ask because you're so lost, call me over and I'll explain it one-on-one with you so that we are able to understand. Okay, here's just a visual of what's going on. If you have, let me change to purple here. Let's just take this top equation and look at it for 1 second. Folks, normally we only have two variables, an x and a y, right? Maybe we had 4x plus y equals 11 in the section before. That was a line, right? You could figure out that line on a graph. And then maybe you had another equation, 2x minus 3y equals 9. That was another line. And how did we find the solution? How did we find the x and the y value, or that ordered pair? We found out where they intersected. Okay, so two equations are lines intersecting. Those are two variables. But as soon as we throw that z in there, as soon as there are three variables, those are planes. So if I just gave you this purple equation and this purple equation, they have three variables. So this is a plane and this is a plane. Those are two planes intersecting. Okay, throw in this third equation with three letters again. That's three planes now that are all intersecting. This is two lines because there are two equations and two variables. Two lines intersecting. But three variables means planes. So one solution, which we just got here, one solution for this system is 2, -3, -2. That would look something like this. 3 different planes intersecting at one point. Okay? Now, let's say these 3 planes had infinitely many solutions. What would that look like? Well, if the 3 planes intersected and they formed a line, which remember, a line has a lot of points on it, infinitely many points to be exact. Or the other thing that it could be is those 3 planes are the exact same. So this is like another plane laying on top of this plane. And on top of that plane is another plane, and they're the exact same. Okay, that would be infinitely many solutions. They're not intersecting at just one central location. Okay, and then we also have no solutions. Remember, to be a solution, all 3 planes have to intersect at some point. But a no solution case would be, let's say this pink and this yellow plane, they intersect over here, but this blue one doesn't touch them, okay? So that's not a point. Over here, the blue and the yellow intersect, but the red one doesn't. And over here, right, the blue and the red intersect, but the yellow one doesn't. So all 3 aren't meeting, right? It's like there's this open area in the center here. It's hollow. So that would be no solution. The other thing it could be is these 3 planes are parallel. They're never going to intersect. Okay. So I just wanted to give you kind of a visual of what's actually going on in a system of equations with 3 variables. There are 3 different planes being intersected. Now, what does that look like, right? I showed you visually what no solution is and what infinitely many are, but algebraically, what does that look like? So this, when you get a system and you have a number equals another number and they don't match up, again, we've seen this before, that's going to be no solution. Okay, no solution because that's a false statement. But when you get a number equals a number and it's true, when that's a true statement, what do we call that? You guessed it. Infinitely many solutions. Okay, again, if you have any questions, please call me over and I'd be happy to help you.